Hello po everyone, so the topic ko po ay graph theory. Introduction of graphs. Think of all various connections we experience in our lives. Friends are connected on Facebook, cities are connected by roads, computers are connected across the internet. So basically, a graph daw ay bilang na nakapokus sa isang concept. Lahat ng na-experience natin na konektado sa ating buhay natin, tulad ng halimbawa sa Facebook ay konektado tayo sa ating mga kaibigan, sa pulya ng graph, sa mga Luzon na konektado rin sa mga kalsada, and also computers. So lahat ng mga ito ay na-involve sa branch of mathematics na tinatawag na graph theory. Ano nga ba ang graph? Ang graph ay a set of points on vertices and line segments or points on edges that connect vertices. So next, in the figure 6.1 and 6.2, similar sila ng graph pero iiba lang ng context. So basically, ang graph ay magagamit ito sa iba't ibang senaryo sa anumang context. So, napansin nyo sa iba-iba yung context na gamit sa graph, pero same sila. Sa left side, ay nagre-represent as Facebook friends, and sa right side naman ay nagre-represent as a baseball team. So, in this figure sa point 1, nakikita nyo itong ito ay nagre-represent as vertices. Itong mga line na ito ay points na nagre-represent bilang edges. Saan ba nagsimula ang graph? Graph is discovered from Onisborn Russell in 1736. Leonhard Euler was a Swiss mathematician, physicist, astronomer, and telegrapher, logician, and discovered many other branches of mathematics. One of their inventions is called graph. And one of the problems is the 7 branches of Onisborn. Basically, ginawa nila yun hard. Sa problem na ito, ay nilagyan niya ng level ang bawat count na nasa connected variable. Ito. Tapos, lumawasan ng graph na may maliit na circle na na-represent bilang count or vertices. At yung line or points ay na-represent bilang bridges. At dahil dito, nakabuo sa ng graph na para mapadali ang problem na ito. In this figure 1, we have 5 vertices and 8 edges. And sa figure 2, meron tayong 6 na vertices and 8 na edges. Sa figure number 3 ay meron tayong 6 na vertices at 14 na edges. So that's all.
This is example of a Euler circuit. Explain ko sa inyo guys kung ano ba ang Euler circuit. First is, every degree dito is once no repeat. It means, return to the starting point. Once na ni-direct nyo, ganito kasi yung example niya, no? Example natin guys, ito ang example niya. Sisimula ka dito ang starting point. Ito ang starting point. Yan. Bawal mo siya balik. 1. Second. 2. Ang 2. 3. 3. 4. 4. 5. Ang 5. Sunod-sunod lang siya guys. 6, 7, 8, 9. So guys, ganito ang sample ng Euler circuit. Once na numeric number siya na lines sa starting point, bawal mo siya ibalik. Tanang direct the shades nyo dito, dapat yun ang ipa-follow nyo. And That's it. Thank you.
Okay, let's proceed on graph coloring. So, ano nga ba ang graph coloring? Ang graph coloring is the procedure of assignment of colors to each vertex of a graph such that no adjacent get the same color. Ang layunin ay i-minimize ang bilang ng mga kulay habang nagkukulay ng graph. The smallest graph of colors requires 2 color. The graph is called its number of that graph. So, ito. Let's proceed on map coloring. In the mid-1800s, Francis Gautier was trying to color a map of the countries of England so that it would be easy to distinguish the countries, and he wanted countries sharing a common border to have different colors. So, after several attempts, he noticed that 4 colors were required to color the map, but not more. This observation became known as the 4-color problem. So, here is the map of the contiguous states of the United States colored similarly. So nakikita natin dyan yung mapa ay may iba't ibang kulay. So note that the map has only 4 colors and that no 2 states that share a common border have the same color. So kung napapansin natin dito sa mapa na to ay walang magkaparehong kulay na nagkadikit. So there is a connection between coloring maps and graph theory. This connection has many practical applications from scheduling tasks to designing computer, and later on this section we will look more closely at these applications. Okay, in figure 6.21, okay, suppose the map in figure 6.21 shows the countries labeled as letters of a continent. So yan, nakikita natin dyan yung countries natin ay nilagyan natin ng label na A, B, C, D, E, F. Okay? So, yung countries ay okay, wait. Okay. We will assume that the no country is split into more than one piece, and countries that touch at just a corner point will not be considered neighbors. So, yun. So, makikita natin dyan na walang magka-same na kulay yung states. So, which is, matatawag nating neighbors sila kasi nga magkaiba yung kulay ng dalawang states. So, yun. And we can represent each country by a vertex. So, each country ay tatawagin natin siyang vertex. Place anywhere within the boundary of the country. We will connect 2 vertices within an edge if the 2 corresponding countries are neighbors. So, nakikita natin dyan dito sa figure 6.22 ay kinonect natin yung each vertex kasi nga hindi sila magkapareho ng kulay. So, they are neighbors. That is if they share a common boundary. So, okay. Let's proceed on 6.23. Figure 6.23. If we erase the boundaries of the countries, we are left with the graph in figure 6.23. As you can see, the result graph will always be a planar graph because, okay, yung planar graph naman and non-planar ay nag-discuss na sa atin yun ni Jann. So, hindi na natin i-discuss yun. Okay? So, because the edges simply connect neighboring countries, our map coloring question then becomes, so, can we give each vertex of the graph a color such that no 2 vertices connected by an edge share the same color? How many different colors will be required? If this can be accomplished, so itong figure 6.23 natin ay kinakailangan lang natin na i-provide dito ng kulay is 3, which is that is the chromatic number of figure 6.23. So, if this can be accomplished using 4 colors, for instance, we will say that the graph is 4 colorable. The graph in the figure 6.23 is actually 3 colorable. Only 3 colors are necessary. 1 possible coloring is given in, okay, yun. Okay, the chromatic number of a graph. So, before anything else, so, i-discuss ko sa inyo muna ano yung vertex coloring and chromatic number. Vertex coloring is a problem of a graph requires assigning each vertex of the graph a color such that 2 vertices joined by an edge are assigned different colors. Ang chromatic number naman is the minimum number of colors needed to label the vertices of a graph so that no 2 vertices of the graph joined by an edge get the same color. Okay, so proceed tayo dito. The chromatic number of a graph. We mentioned that representing a map as a graph always results in a planar graph. The four-color theorem guarantees that we need only 4 colors to color a planar graph. However, if we wish to color a non-planar graph, we may need more than 4 colors. Okay? The minimum number of colors needed to color a graph so that no edge connects vertices of the same color is called the chromatic number, gaya ng sinabi ko kanina. So in general, there is no efficient method of finding the chromatic number of a graph, but we do have a theorem that can tell us whether a graph is two-colorable. So, nakita natin dito sa chromatic number of the utility from section 6.3, note that the graph contains circuits such as AYCZBXA with 6 vertices and AYBXA with 4 vertices. It seems that any circuit we find in fact involves an even number of vertices. It is difficult to determine whether we have to look at all possible circuits, but our observations suggest that the graph may be two-colorable. Bakit? Kasi nga nakikita natin dito, si A, B, and C ay hindi nga konektado sa isa't isa. They are not adjacent. Bakit? Kasi hindi sila connected. And ay same sila ng kulay. Ganon din si X, Y, and Z. No? Parehas sila ng kulay. So, ang chromatic number nito ay 2. A little remaining vertices other, thus the utilities graph has a chromatic number of 2. Okay, let's proceed on application of graph coloring. Okay, determining the chromatic number of a graph and finding corresponding coloring of the graph can solve a wide assortment of practical problems. So, ayan. So, a scheduling application of graph coloring. So, ito yung nakikita natin dyan sa screen. 8 different school clubs want to schedule meetings on the last day of semester. Some club members, however, belong to more than one of these clubs. So, clubs that share members cannot meet at the same time. How many different time slots are required so that all members can attend all meetings? Clubs that have a member in common are indicated with an X in the table below. So, as we can represent the given information by a graph. So, ito, makikita natin dito. We can represent the given information by a graph. Each club is represented by a vertex and an edge connects 2 vertices if the corresponding clubs have at least one common member. Ayan. Have common member. So, yan. Si Sky Club, ayan, may kita, ito yung tinatawag natin yun, yan yung mga scheduling, ayan yung mga vertices natin. So, 2 clubs that are connected by an edge cannot meet simultaneously. If we let a color corresponding to a time slot, then we need to find a coloring of the graph that uses the fewest possible number of colors. So, the graph is not two-colorable. So, nakikita natin dito, hindi lang dalawang kulay yung magagamit natin, mapoprovide natin sa graph na ito because we can find circuits of odd lengths, no? Nakikita natin si Sky Club ay connected siya kay HS, CD, and SG, and CR. So, hindi pwede yung dalawang kulay lang yung gagamitin natin dito. So, however, by trial and error, we can find a 3 coloring. One example is showing odd length below. Thus, the chromatic number of the graph is 3. So, we need 3 different time slots. So, first time slot is Sky Club, Debate Club, Student Newspaper. Second time slot, Student Government, Community Outreach. Third time slot, Honor Society Campus, Democrats, Campus Republicans. So, that's our report. Thank you.
In this video, I will discuss planarity and Euler's formula. Una kong i-discuss sa inyo ay ang planarity. Imagine, we draw a graph and the graph is look like this. And ang graph na ito ay matatawag natin siya na non-planar graph dahil meron siyang edge crossing at ito yun siya. But you could draw a graph without any edge crossing. side, ito yung non-planar graph. And sa right side naman, ito yung planar graph. And a planar graph is a graph can be drawn in the plane without any edge crossing. So, yung wala siyang hindi na nag-intersect yung mga edges. And non-planar graph is a graph that can be drawn with edge crossing. Ito na yung graph kanina na nag-intersect yung edges niya. And a planar graph divides the plane into a region called faces. Planar graph daw is na-divide siya yung faces niya into region. Yung region 1, region 2, region 3, and in fact every plane graph has a bounded region called exterior region, and ito yung region 4. Ito yung kung ano yung sa labas na yun yung exterior region. And another example, we draw a triangle, and saan yung region dito? Ito sa loob and yung exterior region, and that's how we divide a region in plane graph. What you need to remember is that planar graph is the graph can be drawn in the plane without any edge crossing, and non-planar graph is a graph that has been drawn with edge crossing. Next topic natin is Euler's formula. Euler's formula is a connection between various features of a planar graph. Ito yung mga iba't ibang features sa planar graph tulad ng vertices, bases, and edges. And formula niya is E plus F is equal to E plus K. Itong so is a linear na. And Euler's formula is always 2. Let's calculate in our example. Para natin yung vertices. So, as you can see, how many vertices are example? The vertices here is 5. Paano natin nakuha yung 5 vertices? Ito yung point ng line. Ito. Kaya, meron tayo vertices. Ang vertices natin is 5. Next naman is how we get faces. Faces, yan yung ilan yung face sa planar graph natin. Kaya yung kanina, yung region, yun yung face.